my TNC friends, and I'm always available whenever TNC calls. Yeah, I want to talk to you today about our winters in New Jersey. If you notice, recently we've had a little bit of winter. So the question is, are our winters changing? I actually had a question mark at the end of this title, but I decided to remove it because you're going to see there are changes afoot, but not everything is changing. So with that, we'll start with a winter shot I took cross-country skiing over the footbridge from Colonial Park onto the towpath, I think back on February 15th, about a week ago yesterday, in one of my cross-country ski adventures of late. But greetings from the office of the state climatologist. I think many of you listening in, watching, maybe are aware there is a state climate office. If not, now you know. We're at Rutgers. It's an appointed position by the Agricultural Experiment Station, the dean and director of the Ag Experiment Station and the School of Environmental and Biological Sciences at Rutgers via a decree that goes back to the time of Governor Byrne. And our purpose as a state climate office is to work with decision makers, help people make decisions. And also inform them about the weather and climate of our state, past, present, and potentially what lies ahead in the future. And a lot of that is out speaking to individuals, speaking to people from state agencies. Yesterday was a meeting with NJDEP. Today I'm meeting with you folks later this afternoon, early evening, talking to Rutgers Environmental Stewards class of this spring season. So a lot going on, never a dull moment. This month, it's been gathering snowfall data, left, right, up and down. And if you look here, if you can see my arrow where it says winter 2020-2021 snow event totals, you can go and find information on every report we've gotten into the office, separated by counties, with a map for every snow event this season that has deposited 2 or more inches of snow somewhere in New Jersey. I think we're up to about 12 events right now with yesterday's modest snow event. Or you can visit our website, our weather network, which I'll mention later. But the whole idea was we're here to serve the state. It's part of Rutgers University's service as your state university. Enough of that. Let's talk about winter. And there's plenty to talk about, even when it comes to New Jersey. And notice in this, you'll see the Washington Post. And on the left, you see their lead article in a series of articles the Post had beginning in 2019 into 2020 on the global changing climate. And it kicked off with this article, 2 degrees C beyond the limit. And notice Lake Hopatcong, New Jersey is the lead for this. I've worked with the Post on this for about 3 or 4 months, gathering data with them, setting them up with some links up at Hopatcong. And they found old archive photos of ice fishing up there. We tried to find ice fishing records. And we noticed there were fewer ice fishing contests because they had to be canceled due to the lack of sufficient ice. And anyway, this led off this series of articles that was looking in particular at how New Jersey, along with the other areas in dark red on this map, are some of the faster warming locations in the United States. But what I'm most proud about being part of this series of articles is the Post won the Pulitzer Prize last year for this series of articles. So very exciting. So what is it about winter climates and all? And why was last year so darn benign? And this last month has been so crazy, not just in New Jersey, not just in the United States, but at least across the Northern Hemisphere. Haven't checked in too much on the Southern Hemisphere. Well, a lot of people would blame the polar vortex, and there's a lot of legitimacy to that. That's an area in the stratosphere above where our weather develops down into the troposphere where our everyday weather behaves, up in the polar regions. And sometimes the stratosphere warms anomalously and it transfers energy into the lower atmosphere, and that in turn throws the jet stream off, and it becomes a much wavier creature. And with that, cold air can invade middle latitudes. Mind you, also warm air can get up into polar regions as well. Now, last winter, no stratospheric warming, no wiggles or wobbles to the jet stream to speak of, and the cold air stayed where it belonged, and the middle latitudes, we had a very benign winter. That's hardly been the case for the last month or two across the northern hemisphere, with a major stratospheric warming in early January. Add to that an area of research underway for years now, with the Arctic warming faster than the middle latitudes. The thermal gradient between the pole and the middle latitudes is weakened. And with that, the hypothesis is that the jet stream is weakening and getting wavier, and with that, a little more sluggish, which could explain why this cold outbreak into the center part of the country lasted 4 or 5 days last week. So again, a lot of this is cutting edge research. One thing we know for sure, the weather was incredibly unusual across North America in the past week. And mind you, there was a snowstorm in Moscow to lead off the month, the rivals, the one we had to lead off the month. There was snow in the Middle East last week. And on Sunday, Beijing hit 78 degrees Fahrenheit, which broke their winter record for a high temperature, December, January, February, by 10 degrees. So it's not just in the US that things have been going just a little crazy. This shows you an example of this. This is a map from back last Tuesday. And this area right here shows that it is the coldest anomalous temperatures anywhere on the planet, along with a little bit of northwestern Russia last year. Relative to normal, the central part of the country was the coldest place on Earth. Meanwhile, in the Arctic, relative to normal, it was the warmest place on Earth. Mind you, it was still cold up there, but actually Longterm in Svalbard got above freezing last week, while it didn't get above freezing for the week in Dallas. So that just shows you when this jet stream goes wild and the polar vortex breaks loose, all kinds of repercussions across the high latitudes and middle latitudes. And here I might also point out, I heard a report in Kazakhstan, I think it was, hit 90 degrees Fahrenheit last week, which is incredulous. And this warm air, this shows warmer than normal air, is what shifted over to China, Korea, and Japan later last week and early this week. So my point in this slide is you experience the day-to-day weather and climate locally, but you always have to think globally in what might or might not be going on. Similarly, we have to think about our experiences today, be it cold or warm, but we also have to think in the longer term. And this is kind of an interesting figure that shows in the middle to latter portion of the 20th century, mind you, it's for summer, but it applies, this is a kind of a generic figure, if you will. This would be your distribution of temperatures. You'd have some cold, you'd have some hot, most days were close to normal, and you'd have some extreme cold and some extreme warmth. Now, look to the first 10 years, well, 2005, 2015 of this century, and this same stations that were used, this was the distribution of temperature. And you can see everything shifted over to the warm side. So now it's more common to be hot in comparison to what hot was 50 years earlier. And the potential of it being extremely hot is much higher, but still there is some chance of it being cold or maybe even extremely cold. So even with warming going on, you can still be cold every once in a while. And I think that's an important story. When someone looks outside and says it's cold today, what the heck is it with this global warming? Well, the fact is every day has its own identity, if you will. So experience today, whether it be hot or cold, but think of the long-term patterns with our changing climate. And in Jersey, it's being our climate is affected by so many different directions. The battle between continental polar air and maritime tropical air, and whichever wins that battle will dictate what our underlying climate will be for that particular day, week, month, or year. But mind you, it's not only maybe the frequency of these different air masses that can change, but the air masses themselves are all getting warmer. So when the cold comes in, it's not as cold as it used to be. And when the warm comes in, it's a little warmer than it used to be. So we're right there in that squeeze play, in that battle zone here in New Jersey and in the middle latitudes, where we import a lot of our air masses, be it from the polar regions or the tropics, and they battle it out here in the middle latitudes. And when it gets to New Jersey, as we all know, with all TNC's activities from the northwest part of the state to the far south, the weather and the climate can change depending on the altitude you may be at, a couple degrees of latitudinal difference, surface conditions, the pinelands or an urban setting, or down along the coast or in the farmlands of Southwest Jersey, and then the all-important land-water contrasts along coastal New Jersey, in particular, the maritime modification of cold winter air masses and hot summer ones. Here's a great example from 6 years ago, where all on one time, our weather network picked up as a little milder, still in the teens along the coast and in urban areas. In some of the lower lying areas, the Pine Barrens and the valleys of Northwest Jersey, it was below zero. But in the highlands, it was in the teens or low teens area. So that was the case where the cold air subsided into the valleys on a calm, clear night, and the valleys were colder than the hilltops. The urban areas were producing their own heat and were warmer than the rural areas, and the coastal areas were being influenced by the milder ocean waters. So all at once, you had all these factors influencing winter weather in New Jersey. Moving on, let's look at winter in particular. This is a graph I grabbed from something called Climate at a Glance at National Centers for Environmental Information. And there you can plot to your heart's content. And here I looked at New Jersey winters, temperature and precipitation wise, that's December through February, from 1895 to 2020. And then I put a simple linear regression on it. And what this shows for temperature from 1895 to 2020, each year, up and down, and we have the ups and downs for sure, but overall, the winter temperatures in New Jersey are warming at about a pace of 4 degrees Fahrenheit per century. That's an impressive number. And when you look at it, the colder winters of the last couple of decades are somewhat akin to the average winters over the last century plus, even in some cases about equal to the warmer winters of the early 20th century. So we've had quite a change in temperatures across the state. But what about precipitation? That would be rain and melted snow during December through February. No change essentially whatsoever. 0.2 of an inch per century actually decline in precipitation. So there's a question, winter's changing in New Jersey, temperature-wise, absolutely. Precipitation-wise, no, not really. Moving on, something I find really interesting and haven't fully understood yet. So you can see science remains unsettled. We've already talked about the whole global or hemispheric uncertainty with the jet stream. But here in New Jersey, notice how our Decembers and Februarys have warmed significantly more in the last century or more than January. Mind you, January is still warmed, but at less than half the pace of December and February. In fact, January is one of our slowest warming months. And I've got some ideas thinking about what might be involved with the core of winter staying at the core of the cold. But still, this is an area ripe for better understanding and research why Januaries aren't warming as much as the swing, the shoulder areas of our winter. And I might add, November and March are warming at about the same pace as December and February. So that's looking at it month by month. But how about snow? When I was younger, the snow was up on top of my head for months on end. Well, I was shorter then, for one thing. And there's a lot of myths to dispel. Memory can be very selective. You tend to remember the more extreme situations. And when it comes to snow, you remember the bigger storms. Well, I'm working with actually a high school student now on a project for a science fair, and he plotted up New Jersey's February snowfall. We generate regional and statewide snowfall numbers. And you can see the incredible variability of snowfall in February. And look, the last February, it was non-existent in our third least snowy winter on record. Yet this February, it's going to be up there. It's not going to be up at record heights because the southern half of the state hasn't nearly been as snowy as the northern. Witness the big storm here, the beginning of the month. All these areas in yellow had 2 feet or more. And down in South Jersey, there was nearly a flake of snow during that big event. So what about snow? Well, this is a regression line. Snowfall hasn't changed in February. Well, what about the rest of the season? Well, first, let's look at just this century, the last 20 years. And we break the state up into north, central, and southern regions. And one thing you look at this bar graph tells you, every year is different. Is there such a thing as a normal average winter snowfall? Here's last winter. Here's the winter of 2017, 2018. How about 2009, 2010? But we maybe don't remember 11 and 12. So notice the ups and downs we've had in this past 2 decades when it comes to annual snowfall, even more so than it seemed in the past. It's been a little steadier in the past. Well, what about that past? This is 2 ways of looking at it. The top figure shows you divisional, blue, green, red, like in the previous figure, and black is the statewide decadal average snowfall from the 1900s to the 2010s. And one thing you can see is there's no trend in annual snowfall, seasonal snowfall in New Jersey. Now, if you grew up in the 60s like me in New Jersey, that was the snowiest decade of the 20th century and these past 2. So if you think there was more snow when you were a kid, it wasn't just because you were short. It's because there was more snow in the 60s than other decades. But you can see the ups and downs of it. And these are running means for the 3 divisions. And you can see the 60s right out here. So interesting. We've warmed 3, 4, 5 degrees Fahrenheit, but we still are getting as much snow. And why might that be? Well, I attribute that to the magic freezing point. As long as you keep temperatures below freezing and the snow is falling, it's going to continue falling as snow. Now, as soon as you cross that line and you get above freezing, you're going to get rainstorms. But it seems like Jersey still produces enough storms at temperatures below freezing that you're able to keep it snowing. In fact, there's some theorization, an article in the Washington Post I contributed to a couple of weeks ago, kind of went viral and talked about this. As temperatures approach freezing, the atmosphere can actually hold more moisture than it can at, say, 15 degrees Fahrenheit. So if we're getting more snowstorms at 25 to 30 degrees, we might actually be getting more snow because the atmosphere is more moisture laden than it would be at 15 degrees. We're actually working on that right now. This high school student and I are looking at all New Brunswick, New Jersey snowfalls to see if snow is falling at different temperatures than it did in the past. But mind you, still cold enough to snow. So you have to have me back next year to talk about that. So let's finish up by looking at winters in the coming decades. There's nothing specific for New Jersey to talk about here, really worth mentioning. But I bring your attention here to projections made several years ago by the National Climate Assessment, where it looked at the middle part of this century compared to the latter 30 years of the 20th century, and what the differences would be in temperature on this figure. And this shows you everything in reds and yellows is warmer middle of this century than the end of last century. There's no blues here. Everywhere is warmer. But this is specifically for winter. And you can see warming here in New Jersey, warming through the higher latitudes of the lower 48. We can talk about summer. I'll come back and talk summer, which looks to get real warm another time. But warmer winters and wetter. The greens here are areas that would be wetter in the middle part of this century than at the end of last century. Yes, you might say, well, it is dry in the southwestern US. Well, that's dry getting drier. This is just getting wetter. So warmer and wetter up in the upper Midwest, which actually may bring them more snow before temperatures warm past that freezing point. But here in the East, somewhat warmer winters and somewhat wetter winters, probably showing us by the middle of this century less snowfall than we've been experiencing in recent decades, and for that matter, throughout the 20th century. Can't tell you how much, but I do invite you, if you want to learn more about climate change, this is an excellent primer produced by the National Academy of Sciences here in the US and the Royal Society. They just updated it in 2020. Truth be told, I sat on the National Academy of Sciences Board of Atmospheric Sciences and Climate when the 2014 version came out, and we got to review it and vet it, but not write it. And I just think it's about 60 pages. So it's better than a short article, but it's also better than a full book. And I highly recommend this as a non-biased approach to learning more about climate change. And with that, I'll bring it to my favorite use of a golf course for the cross-country skis. It was a lot gloomier on this hole yesterday when I was skiing, but I was out there enjoying it. So with that, I thank you. I'd be happy to take questions.
Thank you so much for that. That was amazing. We do have a few questions here for you. So the first one is, what effects does climate change have on the severity and frequency of winter storms?
Yeah, it's a great question to lead things off. When you get these real wavy jet stream patterns, you are more prone to have strong storms because you've got the warm air and the cold air clashing with each other where they don't normally find each other. And it just so happens we got pretty stormy this month because that jet stream pattern dipped into the center part of the country. And we, if you think of it as a U, we were on the eastern side of that U, and that's a perfect location for storm formation. So if the pattern had shifted a couple hundred miles to the east, we would have been real cold, but not nearly as snowy. And if it had shifted a couple hundred miles more to the west, we would have had a mild and maybe not stormy February. So we were in that perfect alignment along the East Coast to have a pretty active storm pattern over the past month. I hope that answers. And that's a big question about the future. Just where are these wave patterns going to set up? How pronounced are they going to be? And are they going to bring enough cold air down with them from the north to generate snowstorms or just rainstorms?
All right, thank you. And for the next one, are there certain areas in New Jersey that will or have experienced more extreme winter impacts caused by climate change?
Yeah, for that, I would look two places. One's along the coast, where sea level is up over a foot in the last 100 years. And with the big storm at the beginning of the month, there was moderate flooding for multiple tidal episodes because the storm stalled off the coast. A very mini version of what we saw in March of 1961. So, but I would look to the coast with enhanced flooding due to the rising sea levels. But let's also look at temperature, mindless of storms. Look at temperatures. One thing we have found that along with the overall warming of our winters, the coldest of the cold nights of winter are warming at a faster pace than the average low temperatures in the winter. And what that's apparently doing is allowing invasive species to winter over successfully, a case being the southern pine beetle. In the past, it had been cold enough in the winters, at least on a couple of nights, to, if you will, freeze dry the eggs. And without that brutal sub-zero cold on occasion, they're able to winter over, and they're putting a major hit on the pinelands. So that's one way of just looking at it, temperature speaking, and the other more with sea level rise and storms.
All right, thank you. And we have another question. Based upon rising temperatures and more precipitation, is it likely that New Jersey will get more snowier over the next decade or two?
It's actually not out of the question when you say, I love that, you said decade or two, because if you were said 3 or 4 or 5 decades, I'd say no. But for the next decade or two, we still may be able to keep temperatures cold enough despite these big snowstorms. What we're also looking at right now is whether we're getting more of our snow in big events and fewer small events, because the big ones can sometimes generate their own cold. Interestingly enough, they can bring cold down from aloft, and they're often associated with pressure differentials that help funnel cold air down from the north. So we will see if that pattern is recognized in the next decade or two. So I would not put away my shovels or sell them off, get rid of my sleds. I think we're still going to see plenty of winter weather, plenty of snow in the next couple of decades. Beyond that, I'm a little more skeptical.
Okay. And another one, what could happen if the snow on the ground in northern New Jersey melts too quickly?
Yeah. I'm a little worried about that. If you live north of Route 1, I would say. I'm down here in Somerset. Right out the window here, I took a core of the foot of snow last night and melted it down. There was 4 inches of water in that snowpack. And if that all goes quickly, the average precipitation in February is a little under 3 inches of rain and melted snow. So we've got more than a February worth of precipitation locked up in that snowpack. And if that goes too quickly, we could have flooding concerns. So what we're all hoping for is a well-behaved melt, where we'll get our days in the 40s, our nights down below freezing, and it will continue for perhaps a couple of weeks, and we'll be okay. What we don't want is a real rapid warm up accompanied by a rainstorm, because then we're going to be looking at the Passaic Basin, the Raritan Basin, and the Delaware Basin for potentially some substantial flooding. For those been around long enough, the best example of that in the last several decades was in 1996. After a major early January blizzard, we had an incredibly fast meltdown on about the 20th of January, and we lost over a foot of snowpack in half a day, and with a couple of inches of rain. We don't want that.
All right, and we'll do one last question here. Is the climate change evidence and causes article that you mentioned available online?
Yeah, I should have put, excuse me, I should have put the URL on there. Just Google that, National Academy of Sciences, climate change. Let me, whoops, going the wrong direction. Go back to that. It's Google. It can be downloaded for free from the National Academy of Sciences site. And again, it's a pretty straightforward read. Um, it's got graphs, maps. They've all been updated. It's National Academy of Sciences it doesn't do its own research. When you're working with the academy, you're tasked with evaluating or setting policy, setting suggestions for research. Sometimes asked by Congress to investigate something, but it's bringing together experts. It actually started with Abraham Lincoln, the National Academies. So it is, I would contend, the authoritative, unbiased source of such information, as is the Royal Society. So I really would recommend this to, friends and uncles at Thanksgiving and things like that.
Okay, thank you so much. And thank you to everyone who joined us today. We hope you enjoyed the presentation. I sure know that I did. And a big thank you to Dr. Robinson for putting this together for us. We look forward to hosting another webinar with you in the future. All right, everyone, have a great day.
Be well.